5-4. Number 1, I've got a 3 kilogram blue block.
That's fun.
And it's moving at 33.3 meters per second. It collides with a red. That's not red. Where's red? I'm going to have to go orange because I lost my red. It's weird. 2.0 kilogram.
Yeah, it does.
Is that, you sure? It's
Yeah,
just
that's
not
right.
really great. 25 meters per second west. They collide. Some time goes by. And the blue block is deflected at
It did
30
draw.
degrees.
You did draw.
At 30 degrees north of east at 16.6 meters per second. What is the velocity of the, quote, other block? I'm going to draw it this direction. Is it likely to go in that direction?
No.
No. But that would be the positive Vx and Vy direction, so I can solve it. And then when I get a negative answer, I go, oh, it didn't go that way. Right? Momentum has to be conserved. Momentum has to be conserved no matter how I view it. So if I view it in a different direction, if I view it looking from a different way, I can't get different answers, right? So if I view it while moving, I can eliminate one of the two dimensions, x or y. So as such, it must be conserved, not just conserved, but conserved in the x and y directions independently. Agreed?
Mm-hmm.
Another way to look at it is if I'm sitting on this block, let's say this is stationary for our purposes, to make the discussion make sense. I'm sitting on this block, and therefore it's motionless. Okay? I could describe all the motions from there. The momentum has to still be conserved. Agreed? Or I could be riding by on a bicycle this way, and the momentum still has to be conserved, right? So the momentum this direction cannot change depending on how fast I'm going this direction.
Oh, okay.
So therefore, it must be conserved this way, no matter which way I view this. And if it has to be conserved this way, by rotating my frame of reference, it also has to be conserved this way. Okay? So now I'm going to go x direction. In the x direction, what's momentum before?
There is 3
times
33.3
33.3
plus 2 times negative 25
plus 2 times negative 25 equals
3 times 14.37
3 times, how do you get 14.7?
37 because you do the cosine of it.
So I get cosine of 30, so I have to do cosine of 30. Let me get my calculator.
It's 14.
Not that I don't trust your calculator work. It's fabulous at all times. It's the best calculator operator in the room. Bar none.
I just did like.
Let's check.
Did you make sure you were in agreement?
Yes,
Details.
I did think that. What? Yeah, no, but times is 16.6.
So I get 14 point what?
37.
37. All right, 38. Good enough. All right. So everybody good?
14, that's x direction times the mass again. Or
Times the, well, I got the mass, right? So it's 14.38 or 37.
Okay.
No matter which.
Plus.
Plus, and I've got 2 times velocity in the x direction, right? Can I solve velocity in the x direction?
Yes.
Yes, I can. So 3 times 33.3 minus 50 minus 3 times 14.38 gives me 6.76 equals 2 Vx's. So divided by 2, and I get 3.38
In the x direction.
in the x direction. In the y direction, momentum before,
0.
0. Momentum after, I create this piece here, that's 8.3 using sine.
So 2
So
or 3 times 8.3.
3 times 8.3 plus 2 times velocity in the y direction.
And we can solve for that too.
Yep.
Okay.
And I get
Seems like there should be an
velocity
easier
in y direction is negative 12.5-ish. Let's do 4 5-ish. What is it?
Okay, so then it's down.
So that'd be down. So I drew it the wrong direction.
But so it's to the right and down.
So the right and down. So if I were to redraw it, it'd be 3.38 this way and 12.45 this way. So how do I figure out my final velocity?
Draw the hypotenuse,
Around the hypotenuse.
and then it's gonna be the angle there, so it'll be south of east.
Right.
And then do your arctan. or
Wait,
whatever.
which angle do you do arctan on now? Like which one?
Always from where you
draw?
start to where you end, right? So I got 13.6 meters per second at 74.8 degrees south of east. Make sense? Whoops.
In the back one, the first one on the back,
We're coming back.
which is
I
the
don't
last
do the last
equation, which is done.
Yeah, I don't do that.
Station uranium-235 out of spontaneously decays. When it decays, so it's uranium-235. Spontaneously decays, boom, it becomes radium-227 and 2 alpha particles. By the way, what has to be the mass of the 2 alpha particles?
Atomic
Even if you
mass
don't
is
remember.
4.
Yeah, if you don't remember, oh, it says on there?
Yep.
Oh, that's nice of me.
Why
Okay.
is that the case? Oh, to add up.
You have to add up, right?
Oh,
Okay, these 2 alpha particles with an angle of 90 degrees between them. All right, which way am I going to draw those? Let's go this way and down over the left, right? That way we can make that to the right. So far, so good?
Yeah.
Speed of one particle is 3.45. 3.4, sorry, times 10 to the 5th. Speed of the other one is 1.7 times 10 to the 5th. What is the speed of the radiant particle relative to the faster particle? Speed?
boy.
Ooh, that makes that one really hard, but let's not do that. I meant direction or whatever. So let's just find the speed. So far, so good?
Okay.
Now what do? Momentum before in the x direction. Momentum before.
You have 3.
What is the momentum before? 0. What's the momentum after?
The
Wait, isn't that
times
one
the
moving
mass.
along?
Oh, the mass is like calculated at 6.68 times 10 to the negative 22nd or 27. I can't read.
Should
that
be
yet.
negative 27.
Okay.
Times speed was 1.7 times 10 to the 5th. And that would be negative.
Why
It's
is
going to
there
the left.
nothing in the x direction?
Because before it's spontaneously decayed, what's moving?
Oh, the beginning is 235.
Yes.
I thought the beginning was when it was releasing its alpha particles.
Nope.
Why is one going faster if they're the same mass and they have the same collision?
Intermolecular nuclear forces. Not intermolecular, sorry. Interatomic
No.
nuclear forces.
All the fun time.
It's these things don't go well. They go badly. What's happened is some neutrons got misaligned. Probably if this one's faster, it means that this thing was directly in front of what happened. Or that one's getting knocked out of sight because it's falling out. But we're physicists. We don't care about that.
I
That's
don't know what
chemistry.
we're finding because we have the speed for both of them.
I want to know the speed of the particles left over.
Oh. So and then I add,
So that would be 227 v in the x direction.
but don't I also have to add the other alpha particle?
So what?
No, because it doesn't have
Oh,
a
it's going the other way.
They're not going in the x direction.
247? Oh, why do you just keep
Is this
writing over it?
100% review, Mr. Resnick?
Why don't
What?
you like
This is all
physically?
review.
This is all review, yeah. This whole
We
chapter
did
is
all
review.
this last
So
year because it feels
we did this
difficult.
exact same worksheet last year.
This is difficult.
Exact same worksheet.
No, I remember it now.
I remember that. I just don't
Tell
remember.
me if I have my finished binder.
Yeah. Which are I told you to keep, so you should have it.
So we can turn it
I have a
on
large
to
physics
monitor.
1 folder.
Well, except that I changed the order of problems, so there's not quite. Like this is the front half of one worksheet and the back half of another worksheet put together. It's a little tricky. You may have to actually copy.
Yeah, I just
Right, that works too. By the way, you should, since you change this one, I'd have to change this one by multiplying by whatever it is. I gave you the number,
Wait,
didn't I?
multiplying what?
But do you
It can't
have
be
to change it?
227. It'd be 227 times
Why?
1.6 because you did it for the first one. I have to do it for both of them.
What's
No,
4.6
I thought we
times
were
10 to the
finding
negative
it-
27?
So this is 3.79091 times 10 to the negative 25.
Wait, if you have to
Right.
change it though, if it's all proportional.
Well, what happens is what I normally do, because she changed it already, I went with what she did. But what I do is 4 times 1.67 times 10 to the negative 27. And this would have 2 point whatever times 1.67 10 to the negative 7. I just cancel out those. Divide both sides with that.
But why
That's
are
I was
you
wondering where she
multiplying
got
the
here.
radium by that as well?
What?
It's not an alpha particle.
But it also has an atomic mass.
It has an atomic, it's measured in atomic mass. That's
Oh,
what
so
that
the number is its atomic mass.
is. That's atomic mass. So you're a chemistry teacher.
I did really well in chemistry. I just don't remember.
I don't
any of it.
remember chemistry.
Me neither. And my son, the first day of AC Chem, and we're like, Now we're here.
It was awful.
Told you that.
There's like significant digits in 15 labs this year, and I was like, okay, I'm gonna switch classes.
I'm gonna not do that.
I'm gonna not do that.
All right, so you have that. So you can take it from here.
Yeah.
Okay.